In this episode of Finno-Ugric Machining, it will be the final setup for this Kiln PID controller. It will be the housing for the controller itself, then wiring it, and finally tuning it up, setting the parameters, etc. So, let's start. Well, this is my first try to make the housing. Well, I can already reveal that it failed miserably. Well, the reason was that I was not able to silver solder the lid on this ring because the kiln just has too high temperature inside it. Okay, well, that silver soldering didn't go as expected. It was a total disaster. And the reason is the very high temperature of the kiln. It should be around maybe 600 to 700 degrees Celsius. In my case, it was something like 900 and even more. And that actually makes it so that the flux evaporates from there and it leaves just crap behind. So what I'm going to do next, okay. Of course, after I have installed this PID, silver soldering is not a problem anymore because I can control the temperature. So, how to make the lid for the tube? Well, this is 5 mm thick steel plate. I'm now making it a round piece, which I will weld on at the end of the tube. And after welding, I will make it round again and then mill the hole onto this one when it's now ready. So, let's go. Yeah, oh yeah! Get in. Okay. Okay. So. Okay. Well. Yeah. Okay. So, while the paint is drying, well, this should be attached into there, and then it's held with two screws. So let's put this into there. I check that it goes suitably there inside this way. Yep. Yeah. Oh yeah, we got the places for the screws. Good. Okay. Well, okay. Okay. Installed. Well, let's now start to wire this thing. I'll start with the thermocouple wiring. So, well, in this case, I don't want to have dangling wires anywhere, so yeah. Oh, let's put this first in there. This is just upside down. Anyway, it's nice to have. This is just a thing like this. I put it around at that corner. Now we have here place for this, and then okay, now a little bit of a chat of this. It's called an extension cable for thermocouple. Well, it's not just a cable. It's actually part of the measuring element. Well, the wires within are made of the same metal as is the thermocouple itself. So the other wire is other type of metal, and the other wire is the other type of metal. And so the metals are the same as are in the thermocouple. Yeah. So therefore, the polarity is really important. If you mix these, well, yeah, that's not a very good thing. So, therefore, care must be taken to not to mix those wires. Originally, this wire came with this braid, this sleeve. That's not for grounding or anything, it's for protection. But I wanted to have extra protection, and therefore I have this. This is actually a very temperature resistant silicone, and it's very hard to destroy that one. I think it tolerates something like 200, over 200, or maybe over 3. There you are. The high voltage stuff. Well, this is the power cord that goes. I have threaded through the pedestal. There is a hole in the pedestal on the side, and it comes from there. So well, it's well protected. So, how to peel this type of, you could actually slice it like this with a utility knife, or then, like I do, you can bend it like this a little bit. Where is I need my optimizer here. So you bend it, and then you gently, by a knife, do a rocking movement here. It will cut the outmost layer, and then you bend it on another direction and continue with that small little thing you already created there. Furthermore, and be careful not to cut the wires inside. It's very easy at this point to cut those. Like that. We have just a little bit left in here. You can see it's already like all around. And then you just pull. Like this. A firm pull. And then you get this insulation material. And now you have a very nice cut there. And then you have these 3 wires. Well, the color coding. These have a color coding. The green or green-yellow is everywhere in the world. The protective earth, the ground wire. Well, it shouldn't be connected anywhere else, just on the chassis and on the metal parts of the thing. No connection with these two, never. Then we have the blue wire. In Europe, this is neutral. In USA, this might be white, and I don't know what it might be in other countries. But in Europe, this is quite always blue, and in USA, it's quite always white. It's neutral. And then we have the line, which is brown. In this case, well, it's the line. And I think it's the same color in USA as well. Okay. And now it's a very good practice to follow these the guides. If you have some guidance how to connect them, it's very good practice to do so. So, what does our nice little paper say about this? Well, the line should be connected to one here, and then it should go to the controller itself to number 1. So that's the brown wire. And then the neutral should go directly to the heating element and to the controller. And the number 2 here goes to the, well, obviously, it goes to the line for the heating element. Okay. So, let's start with the neutral first. So, well, I made this so that we have here room for 2 wires. Like this, and then we have the heating element. Okay, let's take that one next. This is the wire for that one, goes to here. And then, now I need to figure out, this is some temperature resistant wire. It's very good for this purpose. I need to figure out how long do I want this to be. I don't want it to be like this long. That's bad. And well, it has this receptacle on the other end, which is no more, will not be used anymore. So about that place. So now I cut this from here. it's quite long actually, because, well, yeah, I got it from here. There you go. And then I can use this for some other purposes. The rest of this thing. Yeah, that's done, that one. And now this one also we need to deal with. Okay. And now I would like to put them into this one. So I will put this on this side, like here, and that one to the other side, like here. And please note how long I left these wires. You can always cut them, but okay. And again, you don't need to tighten these like crazy. I'm trying to organize these wires now. Okay. Then let's start with the long one. That's about the correct size. And 1 meter extra. Oh yeah, okay. Then I try to peel it. There you are, like that. And then I will keep this together with that one. Okay, so let's cut that from there. And I'm just nipping the insulation a little bit. Oh, it's okay. So these go to this side, and now I just roll them together like this. Like that. Yeah. I'm trying to get some extra so that I can show you. This is now, they are bound like that together, and then I put them inside here, like that. There you go. And then this should be tightened. Yeah. There you sit, there it sits. Yeah. Okay, that was ground. And then we have yet this ground. I left this alone because this is quite a lot thicker wire. This power cord I have put here is 1 square millimeter cable, which is capable of handling a little bit more current than the normal 0.75 quadrat square millimeter wire. And for this one I peel off a little bit more. The reason is apparent quite soon. It didn't want to come off. No, yeah. And I roll it, and then I bend it like so that it's 2 wires. And now I will show you again this. That one, I bend it, and then I push it into the other side of the grounding connector I have provided here. Why did I bend it? Well, the reason is that it gives more copper in between there, and it hopefully it stays better. Yeah. Okay, there you are. So the grounding is now done. Next will be our neutral. And the neutral is the blue one. We need 1 wire which is going to the controller. And we need 1 wire that is going to the over. And then this one will be connected here. So again the same story. I will have these two together. Okay, now let's strip off this. For a suitable length. It's not very good idea to leave kilometer long wires inside there. It's better to let them. And now again nipping the insulation. There you go. This is a lot easier because I have it here. Okay. And now I roll these two together. Like that. And then I put, oh yeah, this is, now I will, actually I would like to have this doubled because it, oh yeah, okay, it doesn't want to come off. Okay. Let's take some of the insulation away, a little bit more actually. Because the whole power is actually going through this wire. And I want it to have as good connection as possible, and therefore first I roll it like this and then I bend it into two, so it has more copper inside there. Yeah, very good. Okay, now we are talking. And then I just tighten this there. So, and this one goes to the control. Then, number one, which is that one. Number one should have the line. No, we are still having this. The neutral from the power cord. No, not ready with the neutral. So this one goes into that hole. Let's take that much. And then again I will bend it into two, so I take a little bit longer bit out from here. Like that. Twist it. And then bend it as it would be two wires. And then I put it into there and tighten. Yeah, there you are. Okay, now the neutral is done. Then this is the line from the power cord. So we need a line, same color, about. This is going to go into the, and this, okay. Twist it. And I think I will bend it to two, so again. And let's see, this one had another type of connection. Yeah, okay. Well, in this case, I will show you it to you again. The wire actually goes under there. Like that. Like that. you don't put it around the screw. That's wrong place. Okay. That's that, and then this one about well there. About there. And again I will oh yeah. Okay. One half is into there and the other half is into there. And then I tighten it. It should be like that. Okay. Don't want to tighten it too tight or it will crack things. Okay, now we have the power cord to there, to the controller, and then the only thing here is left is this thing, which is the line to the oven. And now again I would like to twist it into two, so boom. There is a trash bin I'm throwing these into. Yeah. Okay. Twist. And bend. And as earlier said, it goes under this thing, not under the screw, but under here, under the washer, so to say. Oh, there was an extra. Oh, this I don't like. A little bit better job has to be done here. Now it's better. Yeah. There you are. Then one thing that is left to do here is the control wires from the controller. And here we have plus and minus, and now I'm using different colors, red and black, which are not present in the so minus is of course black. Yeah. Well, that's the wiring of this thing. Next I will be putting it inside this tube under there. Now let's start wiring this one. Well, yeah, okay. So the first thing is this thermocouple wire, which I push through here. This is just, yeah, there it is. And then I push this one, so that the thermocouple wire goes under, under this one. This is a little bit awkward. Getting all these wires there. Hopefully I can catch them. Okay, at least we need 4. The blue one is... Aha, okay. Blue one didn't follow the others. Oh, now I get the blue one too. Yeah, so here are all the wires. And as you can see, I can push it quite far away into there. And that's good. Okay. Now I just need to, hopefully it stays in place so that it doesn't drop on me. Okay, so now we start with the line which goes to number 1. And here number 1 is, number 1 is okay, 1, 2, 3, 4 and so on. So that's 1. That's 1, and I think we need number 2 as well. Let's see pretty soon. Okay, and now we have a slight problem here. This goes that way, and this corner is really near to a metal surface here. So I need to be extra careful not to put it too close. So when I put the wire in, I have to make it suitably short for the first. Like, I think this is suitably short, and then peel it very little, actually, very little. Like 5 millimeters or so, maybe 7 in this case. Okay, that's 1. And same applies to the line, as to the neutral as well. The number 2 was neutral, was it? Yeah. So I need to cut this off and peel it similarly, very, very small amount in this case. Okay. And these 2 are the blue was the neutral and the brown was the line. I twist these, and then now when I put this in, I put it on as far as possible away from any metal surfaces. So there it should be. And it was number 1. Having this wrong will turn your controller into smoke. There you are. And then number 2, it's this. Goes there under. Okay. Okay, that's that. And then we have these 2 wires which are, well, the output. And these go to 6 and 7, so that 6 is the, these 2 here, I believe. Yeah. So that, let me see, I have to recheck that one. I first open these. Okay, a little bit more, because these were very, very thick. Hopefully it doesn't off. So 6 is minus. This is minus. So it goes this way, okay? Yeah, so about that much. So this was for 6. 6 was minus, was it? I think it was. That was for 6. And then this was for 7. Well, I should have chosen a little bit lighter wires for these, but okay. So 6, one more check. 6 what? Yeah, 6 is minus. This is just funny layout on that one. So 6 is minus. Can I push it? No. Open it a little bit more. Not too much so that it won't drop. Okay, now it's under there. And then I tighten it. And I don't tighten these again like crazy. You tighten them so that they stay in place, well, and in contact. Okay, and it was like that. Okay, looks good. And now, so this was, I think these two here, like 9 and 10. The numbers are really tiny here. 9 and 10, yeah, these two are the thermocouple. The thermocouple goes so that 10 is minus. And now, don't mix the wires here. This is something that if you do that, you won't succeed. So, as I told earlier, this extension wire, this has the same different metals in the wire as do the thermoelement itself. So, minus must be connected to minus here. So, there is a slight red and slight blue, and I assume that the blue one is minus. Well, I think it's a decent assumption. And this is somewhat difficult. Why does it want to go? Now it wanted to go the correct way. And this one, these are really flimsy. So hopefully they stay in place. These are really flimsy. Well, yeah, that one stays, and that one stays too. So, actually, this device is measuring the temperature difference between this point and the point inside the oven. That is what it is measuring. And therefore this device has an inbuilt thermometer so that it knows what is the temperature at this point. And yeah, so okay, now I pull this a little bit away like that. And I should be able to slide the whole thing in. There you are. Okay. And then the only thing to do is to put the M6 screw under here. Where is the hole? Oh, it's painted. There is paint. Oh, there is that one. Where is it? Oh, now I found it. A lot of paint in it. Okay, now, there you are. Oh, now it goes. Yeah. Well, it's not straight. But that's okay. It's very good. Well, now it's not on a steady surface, but when it is, you can really push these buttons and not just try to. Okay. This is now the PID controller we are going to set the parameters to. It's of type DTXG-FK10-V*AN. Well, I'll put this on the screen. Well, let's power it on and let's see what happens. Well, first it is telling that it is going to show the temperature in degrees Celsius and that the temperature sensor is a thermocouple of type K. Now it is telling the temperature limits. The minimum temperature you can set is 0 degrees Celsius and the maximum is 1362 degrees Celsius. The controller is now running and it is telling that the temperature of this kiln is at the moment 15 degrees Celsius, which is the ambient temperature of my workshop at the moment. It's a little bit chilly. And then my desired temperature would be like 0. Well, this cannot cool down, so it does nothing. The red numbers at the top are the process value. In this case, it is telling the actual temperature inside the kiln. The green numbers are the set value. This is, in this case, the temperature you would like to be inside the kiln. When this light is on or is blinking, it indicates that the controller is tuning the PID parameters. Whenever this light is on, the solid state relay is activated and the kiln is warming up. These two lights are for the alarms and are not used in this application. The set button is used to set the set value. It is also used to access the PID parameters. The shift key is used to choose the number to be modified. It is also used in combination with the set key to access 3 additional sets of parameters. The down button is used to decrease the value of the chosen number. The up button is used to increase the value of the chosen number. Now let's change the set value. So I use the set button to start modifying the value. I use the shift button to choose the number to edit, and then I use the up button to modify the number that was chosen. Finally, I use the set button again to accept the modified value. And now the output light is lit because the set value is higher than the process value. So let's put the set value back to 0 because we don't want to warm up this kiln yet. Now let's go through the first set of parameters. Parameter setting mode is entered by pushing and holding down the set key for 3 seconds. In parameter setting mode, the red display is the parameter name, the green display is the parameter value, the set key is used to switch between parameters, and the arrow keys are used to change the value of the parameter. Setting this parameter to 1 enables the automatic bid parameter tuning process. It will drop back to 0 after that process is complete. The manual states that this is the auto correction switch, and there is no more information about this. Since I don't know what this does, I leave the value alone. This is the timing parameter for the solid state relay. Be sure not to set this to 0, but something else. This value, 20, seems to be working alright. This is the integral time slot. Well, it should be something else than 0, and it shouldn't be too large either. 90 seems to be quite good value for this one. This is the derivative time slot for the PID control. In my case this is something like 20. It could be larger in your case. Don't set it to 0 though, because this will disable the derivative part. This parameter controls the impact of the integral part to the heating process. If this figure is 100, then integral part has the full impact. If it is 1, it has the minimal impact. If there is a lot of overshoot on your warming, then you could try to make this value a little bit smaller. This parameter controls the minimum time the solid state relay stays on. Just don't put a 0 value here. This parameter is used to fine-tune the measurement of process value, meaning the temperature inside the kiln. Well, I leave it alone because everything seems to work alright. This parameter contains the log bits for the parameters and set value. This bit logs the set value, so you cannot change the set value if you put this to 1. This one logs the alarm values, and finally this one is logging the parameters. Be sure to have these as 0 when you are trying to modify the parameters. Now we are back at the first parameter. Pressing the set button multiple times will just circulate the parameters in a circular fashion. To exit the parameter setting mode, the set button has to be pushed and held for 3 seconds, and then it goes back to the operating mode. In order to access other 2 sets of parameters and the usage counters, you have to push the set and shift buttons down simultaneously and keep them pushed for 3 seconds. the code is not a parameter at all. It is used to select between the two additional parameter sets or the usage counters. This is the type of the temperature sensor. In my case, it's a thermocouple of type K, so this should be 0. This is the selection between Celsius and Fahrenheit. If you want to see Celsius, this is 0. For Fahrenheit, set this to 1. Manual states that this parameter is of type omit. It's not just omit, it should state don't change. This parameter defines the functionality of alarm 1. I don't use alarm in this application, so I disable it by setting everything here 0. This is setting for alarm 2 and it is also disabled. This parameter controls the type of control and the type of output. 1 here means that this is a heating device, which is okay for me. 0 means that it is a cooling device. 0 here means that the device switches the output on and off. 1 would mean that the output would be a current loop, which it is not. So this is better to be 0. These are settings for excitation alarming. Not used in this application, so it is disabled. Parameters 8 and 9 are to be omitted, so I don't change them. With this parameter, you can switch the autocorrection and the run stop functionalities on or off. I have switched both of them on. This is yet another omit parameter. Now let's see the third set of parameters. This is the maximum value for set value. In this case, I cannot enter value that is more than 1362. This is the minimum value for the set value. So I cannot enter negative numbers. This is the output high level voltage without load. I don't know what the units here are, and it works, so I don't fiddle with that one. This is the digital filter time constant. This is the time that it uses to average the input and then use that as value. Time in seconds, after which the value, if it has remained the same, is assumed to be stable. This is the multiplier to be used in calculation of the proportional value. This is the multiplier to be used in calculation of the integral value. Let's take a look at the 3 parameters which you cannot modify. This is the maximum ambient temperature of the input terminals. In this case, if the ambient temperature exceeds 60 degrees Celsius, the unit won't operate correctly. This is the maximum use time of the instrument, less 10,000 hours. This is the minimum use time of this instrument. Well, that was all about the parameters of this instrument. In order to exit this mode to the normal operational mode, press set and shift buttons and hold them down for 3 seconds. Now, let's initiate the automatic PID parameter tuning process. Enter the parameter setting mode by pushing and keeping the set button down for 3 seconds. Now, set the value of this parameter to 1 and then exit back to normal operational mode by keeping the set button pushed for 3 seconds. Next, I select a temperature that is in the middle of the usable temperature range. In my case, this is 500 degrees Celsius. Now, we just sit back and wait for the PID process to finish. It will take some time, because in my case, it will heat up the oven to 500 degrees. After that auto-tune lamp stops blinking, then this controller is ready for use. It actually really works. The PID tuning process actually ended up quite successfully. It overshoot like 200% at first, but then it realized that it has to do it somewhere else. And finally, when it got it, it was level the temperature. It kept it as it should be. Okay, well, that's now done. I have a working kiln which I can use for heat treating metals. Okay, in the next episode of Finno-Ugric Machining it will be the rotating welding positioner. We are going to attach the motor to the body of this thing and rotate it for the first time. So, till then, bye!